Thank you very much. Hi everyone, I just want to say thank you for my talk titled of Microchips and Mammals. Point to anyone who got the Steinbeck reference there. I'm going to skip a who am I because I'm going to cut the time pretty short and I'm just going to jump straight into it. So I'm sure at this point the Flipper Zero needs no introduction, but just in case, it's this little gadget that I'm holding here. It comes packed with various technologies to interface with all sorts. Sub-gigahertz radio, infrared blaster, I guess, Bluetooth. Hopefully you managed to avoid that Bluetooth spam attack. The one that really caught my eye was the RFID reader, writer, emulator. So I was looking through the extra actions in the RFID menu, and I noticed this feature here, the ASK. And the animal bit really caught my eye because if there's one thing I love more than hacking, it's animals. And I knew, as soon as I gave a talk about pet microchips, I knew this is what people would really come to see. So here are some of the various animals that take up way too much of my time. I had a hunch this ASK feature was to do with microchips. So armed with my Flipper Zero in one hand and a handful of dog treats in the other, I called my dog over and I tried giving it a scan. And sure enough, I got a read. So I was now looking at my pet's microchip. So let's go over what information we have available. At the very top, we've got FDXB, so that's the protocol that it uses. We've then got a load of hex. We've got an ID, and I'm going to kind of run through this talk as I knew at the time. So I was guessing that this was probably the bit that would be useful to the vet. We have confirmation my dog is in fact an animal. And then we have the very descriptively named bits, and these are all zeros, so there's not really much we can glean from this. And don't worry, I haven't used, this isn't my dog's actual microchip, it's a randomly generated one. I'm not going to dox myself in my first con talk. So now that I've read the microchip, I wanted to have a backup of it just in case. I copied the file over to my computer, but when I used cat to open the file, and pun not intended there, but very much enjoyed, I noticed that none of the actual information was there. I've not got the actual key. And I'm going to use information to refer to stuff like the ID and data to refer to the hex. So this got me wondering, how is that data converted into the information that the vet can actually use? First step was doing some research, and this was filled with some highs and lows. The Flipper Zero's firmware is open source, but my C is awful, so that really wasn't much help. There is public documentation for FDXB, but it didn't really correlate with what I was seeing on the Flipper. When I looked at all this information, I should have been seeing more data than I actually was, so that led me around in circles and again wasn't much help. So I guess I had to do it the slower but the more fun way and work it out myself. So the first step was to establish an upper and a lower bound. I wanted to make sure there wasn't any sort of weird inversing or anything like that. So I set everything to 0 to make sure that it all resulted in 0, and it did. And then I set everything to S to give myself the maximum. So I now knew what I was kind of working between. I guess that the different parts of the hex would convert to the different parts of the information. So for me, the next stage was to figure that out and kind of where that boundary lies. So I walked one through each and just made a note of what was changing. I mentioned there a pitfall. I forgot how hex works. I will elaborate on that in just a bit. So eventually I found that point where the information changed. It goes from the ID to its prefix, so I could focus on just getting the ID. Time to just work on how that's actually encoded. So some of the eagle-eyed members of the audience might have noticed this while I was walking the one through, but at that time I wasn't really focusing on how the information was changing, just that it was. One of the mistakes that I made here was that while I was learning about binary at school, I only really focused on most significant bit first. So that's kind of how I was facing this. I was doing it from the very end there. And you can see it goes from F, E, D, and the data goes 06, 03, 04. It kind of jumped around. So again, I was trying to sort of work my way through there and it just wasn't clicking. It took me way too long to try this, but I decided to try it from the other end, and this did help move things forward. I still wasn't quite realizing why the lowest I could get was 8, but at first I considered maybe just worked in weird intervals, maybe it jumped, but that's not how binary works. That clearly wasn't right. Then I came to the realization. So I mentioned that pitfall earlier about forgetting how hex works. The mistake was that I kind of forgot that hex can be like a representation of the binary instead of the actual data itself. So when I broke that hex down into the binary, I realized what I wasn't seeing. So it said that 8, and that's because of those trailing zeros. We're reading from left to right here. And obviously 8 in binary is at 0001, so that's why. So it seemed counterintuitive, but I tried a different number, a larger number, and hoped to get a lower ID. And yeah, that worked. So I did actually manage to get the result I was looking for. Again, seemed counterintuitive, but as long as it works. I tested a few times with random numbers. I generate a random number, convert that into binary, into hex, and then wrote it to the flipper, and this will seem to work. I was getting the same information on the flipper that I was getting on the actual, like the number that I generated. So now that I've figured out that ID's encoding, I can move on to that prefix before it. I started in the same way, but I noticed that sometimes when changing the prefix, that ID changed. Now remember, when I was working out the boundaries, I thought I wasn't meant to be touching that part. So clearly I was missing something. I had to go back to the drawing board. As mentioned, I thought it was that second hex character in that 5th byte where the prefix ID started, but that wasn't really working out with what I was seeing. I again broke the hex down into binary to reveal the answer. So in reality, it didn't really elaborate on this much, but the green there is the ID, with the blue being the rest, and that's actually where the boundary lies. I kind of assumed that it would all fit nicely into the hex, forgetting that it doesn't have to. Of course, it can kind of bridge it and work halfway through. So once I did that, I was able to, again, generate random numbers, but I tried with larger numbers that would really lead to ones being in that bit, that sort of gap where I thought it would be. And again, that all worked. I got larger numbers, all managed to get it correct. So I kind of glossed over this because I was just testing, but I'm actually going to talk about how to decode the information. So you get the hex and you break it down nibble by nibble into binary, as I've done there. Remembering where the sections between the ID and its prefix lie, you just split it into those two parts, and then you work out each part, convert it from binary into decimal. If you're typing it into a calculator, which I would recommend overdoing it by hand, remember that we're reading, most calculators, like binary calculators, work most to least significant bit. Remember, we're doing the other way around. I spent way too long reading it the wrong way. But you can see here, after converting the binary into the decimal, we have got the same numbers, the 589 and the 163. We can see that is actually how that ID works. So let's go over what we learned so far, kind of recap. The main ID is stored in the first 38 bits. That's when counting left to right. The next 10 bits are the, as I call, prefix. I actually looked this up afterwards, like I say, kind of working with it as I know it. That's actually a country code or a manufacturer code. It depends on the kind of laws in the country and the individual manufacturers. So that's the next 10 bits. The binary doesn't have to, I say fit neatly, I guess kind of work neatly within the hex. Obviously, if you've got a long string of binary like that, the different sections can obviously span the different hex characters. It's too simplistic to just think that everything's going to fit nicely. And then the hex is a representation of binary, but doesn't mean that, no, sorry, I'm rereading my notes here. Binary can be read either way. Right to left is more common, but always good to bear in mind it doesn't have to work that way, so you don't spend too long trying to hit your head into a brick wall. So this is the bit that made me really want to give this talk. I've seen online some people trying out the Flipper Zero's FDXB feature and posting about it, and that's great. Seeing people experiment with it and playing around is what made me really want to give this talk. They recognize the risk of posting the ID, so they've redacted it, sort of like how I've done here. But remember though, as we've just learned, the ID is actually read from left to right. So although they've covered the end of the ID, yeah, there we are, that's a realization. It's all actually in the hex there. It was utterly useless. I did message some people saying, just to let you know, you've, not redacted it at all. I got no responses. I don't think anyone deleted any posts. I don't understand myself, but there we are. I would say a better redaction would be something like this. Obviously, we're now covering the actual part of the data that converts into the information. How much you want to redact is up to you. It's personal choice. You might decide to do the whole ID. You might decide to leave the country code. You might decide to partially redact. that's fine. Just make sure you actually know what it is you're redacting instead of not at all. So unfortunately, I wasn't quite able to discuss how all the data was encoded. I wasn't able to work it all out myself, and I'm just being told I've got 5 minutes to wrap it up, so I've decided to leave this as a challenge to the audience. That's my excuse, at least. I have seen, and this is albeit rarely, there's sometimes a temperature stored at the end of the chip. You might sometimes see, I might have to, so there's that T colon, and that's sometimes the temperature. I haven't been able to work out how that's encoded. I also haven't been able to find out much information on the bits section at the end. All the information that I found, all the documentation, all just calls it extra information in quotes with no indication as to how that's useful, what systems might use that. So that's another challenge. If you do find these out, please get in touch. My Twitter handle's down there in the bottom left. The prize for that is that I think you're very cool. Not really got anything in the term of monetary prize, I'm afraid, but get what you got. I'm going to wrap this up, and I always suck at doing endings, so I'm just going to say thank you everyone for coming to the talk. Really enjoyed doing this, and I appreciated it. And yeah, thank you.
Thank you. Questions? Yep.
Not so much questions as much, but challenge accepted.
Challenge accepted. That's
no,
brilliant.
Some of the bits at the end are used for vaccinations for certain things like parvovirus.
Are they?
Yes.
Okay, well, you win the prize. I think you're very cool. That's really interesting to learn now.
So actually, I do have a question which kind of follows on from that this isn't a proprietary system that you're using that one manufacturer is making them. This is an open source. So that data that you've spoken about and the data that you've spoken about must be defined somewhere.
It's
surely
per manufacturer. Each manufacturer can have their own interpretation of it.
I also
Not consistent.
could have saved myself a lot of time by just reading the ISO standard for this, which does outline how it all works, at least in theory, but that costs like 40 quid from their website. So
it's probably behind an ISO standard.
Probably. ISO, I can't remember the number, 118 something.
Anyone else?
I also want to say none of this is exclusive to the Flipper Zero. I have tried doing it with a Proxmark. I didn't have one at the time, hence why I gave this talk very Flipper-centric, but I have done it with a Proxmark 3. It actually it still doesn't tell you. So when I mentioned about how all the websites I gave, I should have been seeing more data, it actually gives you less. It tells you less of the hex that's on there. So you can do it on other stuff. I'm not saying it's Flipper-centric, but that's just what I used. And obviously anything that can read microchips will probably have a feature for this.
Thank you again.
Thank you very much.